So these days, folks, computers come with computational units that often they come with several computational units that can do work. You may recall from an earlier portion of your life hearing about the CPU of a computer. Well, it turns out that these days you have many kind of, these used to be called electronic brains, these sort of pieces that do work within your computer, do the calculations. And Anylogic is pretty good about exploiting those to a point. It's got limitations, and some of the questions here that I was addressing about scalability are associated with these limitations. So broadly speaking, there's certain types of highly resource-intensive operations in Anylogic, to wit, sensitivity analysis and calibration, where Anylogic directly makes, there's what we call embarrassingly parallel operations. There's things that can go on in parallel very directly. So you run the model with different parameter values, for example, and you can run different, one model running with this parameter values, another one with this set of parameter values, and you can run those at the same time. And so if your machine, as is typical the case, virtually, I think anyone in this room's laptop these days will have at least 2 cores, often 4 cores. It's even possible someone will have 8 cores here. Maybe Ante is 16. I don't know. But basically, what that translates to is for these big operations, like sensitivity analysis, like calibration, the model can essentially run up to fill in the blank 4 times faster, 8 times faster. It can chunk through the work much, much, much faster. What Anylogic doesn't use cores for, in which it could, in which we've talked, I think, with them a little bit about doing this, and where there's some people who do it, and but it requires a lot more sophistication, is actually running different, like in a given realization of your model, a given run of your model, running different sets of agents with different cores. And that can be done. There's a theory behind it. You can divide up the network, so this area of the network is done by this core, that by that core, and there's less coupling between those areas, and so the cores don't have to communicate that much. And you can do it, but you can't do it in Anylogic right now. I'm hoping down the road maybe they'll create a version that can be mapped to GPUs and these massively parallel cores, and we're working on that with our stuff, and when we finish it, we'll show it to them and say, look how big a gain you'd get. But a lot of it is encumbered by language. Now, if they could switch to Scala instead of Java, they could start to make use of GPU codes for Scala. But anyway, now we wax nerdy. I know you folks probably think like I never wax nerdy. Sorry. But I never left the nerd space. But now we're in like a sub-corner of it. In any case, the point is that there is opportunities for making models run faster. Anylogic has done an admirable job and a respectable job of exploiting the fact that your computer can run things in parallel in general. And often, ladies and gentlemen, if you want to run your model to secure confidence about its behavior, do you remember the model results we saw yesterday? Do you remember that they varied by this thing called a random number seed? Remember that? If you run them with one random number seed, you get one set of results. You run them with another set of results. Remember that? Yeah. So if you want to develop confidence about your model results, maybe when I say results, maybe I talked about the gain of this intervention versus that one, for example. It behooves you to run the model many times. So you develop some sense of the variability in the degree of results. Because maybe you run it once, and you say, wow, look at that gain from that intervention. But maybe that was the luck of the draw. Maybe that was just a fluke. And maybe you run it the next time, and it's reversed. You'd say, wow, our intervention is doing really lousy, or it's showing no effect. You run it again, and it's a fluke. It shows it was a fluke the first time. The point is that without running your model several times, you can't really have a good sense of the variability of those results, and it's hard to come up with firm conclusions. So in general, and I think this may be what Ante was getting at, that generally speaking, as part of model operation, while you might do one-off runs to your model, for quick experimentation, to develop a conviction that you really have found something interesting, you're going to want to run your model many times. And you can do so in parallel using Anylogic. It can run these so-called realizations of the model. It calls them replications of the model many, many, many times at the same time. And so maybe you want to run it 20 times. And you look at the variability of the results. And maybe you find it's all over the map. But often, you find actually it's pretty defined bands. Do you remember I showed you that in my case study slides? There was this kind of band of stuff. So what you typically find, folks, is structure determines behavior. And so there's some variability, but the broad outlines of what's there are pretty regular. It's just that there's uncertainty within a certain range. How big that range is, for that, we've run it many times in parallel. And Anylogic is pretty good about doing that, about running these things many, many times. So we'll be seeing that probably tomorrow. Probably tomorrow we'll be running a model many times, and that will be a lot of fun, I think. Okay? So thank you, Ante, because that speeds it up very materially. That's where you'll get like a 4-time speed up like that because of the cores. You can just tell it, use my 4 cores, go for it, and it will speed it up. Yeah?
If your audience or stakeholders want to see something like comparative runs and a time plot,
Yep.
you put that in, so you don't want the little circles or the men or
Right.
whatever, you want
Yep.
the time plot.
Yep.
If you left that off that kind of cross
Mm-hmm.
thing,
Yeah, yeah.
word,
Sure.
it doesn't have any, if you just left it off,
Yep.
it doesn't affect your model at all. It's just purely for presentation.
I have 2 interpretations of what you're saying. Maybe you can help me figure out. So what I'll do is I will